Happy afternoon. Myself Mohan, Assistant Professor, Department of Agriculture Engineering, Sri Shanmugha College of Engineering and Technology. Today I'm going to share things about basics of strength of material. Actually, when external force it acts on a body, the body tends to undergo some deformation. Due to cohesion between the molecules, the body resists that deformation, that resistance by which the material of the body oppose the deformation is known as strength. So when we applied any load on the material itself it is having a strength. That strength it opposes the load to overcome from the deformations. If it is undergoing deformation, the load is maximum, the material strength is minimum. So the resistance by which the material of the body opposes the deformations. Without any deformation, when there is a load applied on the material, which is known as strength of materials. Here in the case of strength of material, within the elastic limit, that is why we say certain limit, the resistance offered by the material which is proportional to the deformation, and that deformation is because of the external force. Also, within the limit of resistance is equal to the external force. Beyond the elastic stage, the resistance offered by material is less than the applied load. So within the elastic limit, the stress is directly proportional to strain. As per Hooke's law, within the elastic limit, the stress which is directly proportional to strain. So in case of constant of proportionality, we are removing this directly proportional and equating with a term called E. That E is nothing but Young's modulus of elasticity. So once if it is crossing beyond the elastic limit, the material starts deforming depending upon the applied load. That's why here it is mentioned that the resistance the resistance offered by the material is less than the applied load. So it starts deforming. So within the elastic limit, the resistance offered by the object or the member that is equivalent to the applied load. So there is no deformation occurs. When I am removing the external load applied on the member will behave or it will be equaling like as a original member. So this resistance force per unit area, this resistance of the material or object force per unit area is called stress or called intensity of stress. It is denoted by the symbol sigma. Unit of stress is Newton per meter square, or it is in millimeter square. The force of resistance per unit area offered by a body against the deformation is known as stress. The external force acting on a body is called as load or force. It has been written as sigma is equal to P by A, where P is the applied external load, A is the cross-sectional area of the object. The unit is Newton per meter square. Strain. So when a body is subjected to some external force, there is some change of dimensions in the body. So the ratio of change of dimensions of the body to the original dimensions is known as strain. There are four different types of strains are there. One is depending upon tensile stress, tensile strain will be developed. Compressive stress, compressive strain will be developed. Volumetric strain, shear stress and shear strain will be developed. So if there is some increase in length of body, or object due to external force, the ratio of change in length by the original length is called as tensile. Tensile is elongation. There is a decrease in length either in the breadth of the object or the depth of the object, that there will be a decrease when any object tends to elongated, the cross sectional breadth, depth, it is tends to decrease. So there is a decrease in dimensions of the body to the original dimension is called as compressive strain. Then the ratio of change of volume to the original volume is called as volumetric strain. The strain produced because of the stress developed by shear is called as shear strain. Type of stresses: the stress must be normal or a shear stress. Normal stress acts perpendicular to the axis, that is area, represented by sigma. The normal stress is divided into tensile and compressive. Elongation is tensile, compression is compressive, that is reduction, contraction. Here let me have an example. I have given some image here. So where there is a bar or object, in that two applied load is stretching the object. Let me see. The resisting force is applied at the end of the object. So the rod tends to elongate it. So because of this stretching, the rod tends to elongate. That is, the length can be increased because of the stretching force which we applied at the end of my bar. So the stress induced in a body when subjected to two equal and opposite pulls, as a result there is an increase in length, that we can say it is called as tensile strain. The ratio between the increase in length to the original length is called tensile strain. Here let me have the pull, that is called as force acting on the body. A is a cross-sectional area of the object. The change in length is del L. So because of the force which is acting on the body, the normal, that is actual length L, tends to elongate. There is an elongation called del L. Strain, obviously a change in length by original length. So here there is a decrease because of the compressive force which is acting on the two sides of my object. There is a decrease in length of the body, which is known as compressive stress. The ratio of decrease in length to the original length is known as compressive strain. The compressive stress, which is act normal to the area, so which pushes on the area so that the dimension gets shortened or contracted. So the width and depth of the object tends to decrease. So because of the force acting on the object, the strain will be developed. Here let me go with the elastic and elastic limit. When external force acts on a body, the body tends to undergo some deformation. If the external force is removed, the body will come back to its original position or shape. That means without having any deformation, the object will come back to the original position or original size. That we can say is called as elastic body. That property of the material which comes to the original position even after the removal of external force, it is called as elasticity. The body will regain its previous shapes and size only when the deformation caused by the external force is within a certain limit. There is a limiting value of force up to and which the deformation completely disappears on the removal of force. That we can say is called as elastic limit. So as per the Hooke's law, we are intimating that. So within the elastic limit, the stress will be directly proportional to strain. When there is an increase in stress, there will be increase in strain. So the Hooke's law will be valid only up to an elastic limit. So this is about the Hooke's law that we have discussed. So when we are removing the constant of proportionality, we are using the constant term that is called as E, that is modulus of elasticity or modulus of rigidity or elastic modulus. Then modulus of elasticity where E, so sigma is directly proportional to stress. You are replacing constant E, so where E is equal to stress by strain. The ratio between the stress to the strain is called as Young's modulus or modulus of elasticity. It is denoted by the symbol E. And the Young's modulus value for the steel is about 1.9 into 10 to the power of 5 Newton per mm square to 2.1 into 10 to the power 5 Newton per mm square. Then the modulus of rigidity, the ratio of shear stress to the corresponding shear strain, and also within the elastic limit, it is known as modulus of rigidity or shear modulus. It is denoted by the symbol CGN, where shear stress by shear strain, that is a tau by pi. Then let me go with this analysis of bars with respect to the varying cross section. We have a different length, different diameter and cross-sectional area of the bar that is attached as a single bar. when we applied the load on this bar, how this elongations will be. So here the P is the load acting on the cross section, the end of the cross section, length area that will be for the cross section 1, A1, A2 will be, sorry, A2, L2 will be the length and cross sectional area of the member 2 or section 2, L3, A3 for section 3. The stress for the member 1 stresses load by area where sigma 1 is equal to P by A1, likewise P by A2, P by A3. So now I'm just equating the strain sigma 1 by E, that is we have the value of sigma 1 P by A1E. When I'm acting, all the sections are attached as a single section and behave as a single section. So with respect to that section, I'm equating all the strains. That means I'm adding all the strains. Where total strain I have to calculate strain for the section 1, strain for the section 2, strain for the section 3. So where del L, there is a change in length, or the strain is equal to, or total elongation is equal to strain in the section 1, epsilon 1 plus epsilon 2 plus epsilon 3. So epsilon 1 value is PL1 divided by A1E plus PL2 A2E plus PL3 A3E. So when I'm equating, so when I'm here, E is common because it is all made up of a single material. So the Young's modulus of those materials are same when I'm taking E is outside, and also the load is common for all the three sections. When I'm taking P by E is outside, so we have L1 by A1 plus L2 by A2 plus L3 by A3. This is the total deformation or total strain or elongation developed in the varying cross section when there is a load applied at the end. In case if these three sections are made up of different material, the Young's modulus values are different. So the total change in the length of the bar, that is del L is equal to P. The load is alone constant. So we have this L1 by E1 A1 plus L2 divided by E2 A2 plus L3 divided by E3 A3. This is the elongations in the bar or extension of the bar due to the applied load. So next session we'll discuss about analysis of varying cross sections with respect to thermal stress. So thank you everyone.